Uh, Today the topic under the discussion is the U8251 USART. As we know that most of the microprocessors are designed for the parallel communication, and we also know that if we are doing parallel communication, that uh, the number of bits depends to be transferred depends upon the number of lines available. So, if 8 bits has to be transferred in parallel, then 8 lines must be available. So, if we want to transfer the data over a long distance with the help of parallel communication, then uh, it uh, it is not an economical one since it increases the cost of the cabling, and it is impractical too because there are many devices which does not accept the parallel data, for example CRT terminal. So, we have to use serial communication in the microcomputer system, and while using the serial communication, we must be facilitated by those devices by which we can transfer the data serially to the other devices from the microprocessor. So, as far as the basic concept of the serial communication are concerned, it depends upon its classification, the way it is being transmitted, as well as the different devices which are required for the interfacing. So, as far as the classification is concerned, on the basis of how the transmission is being done, it is classified into three. One is simplex mode, half duplex mode, and the full duplex mode. Now, in simplex mode, the hardware which is used for the data transfer take place in one direction only. So, simplex mode is a mode in which the data is being transferred in one direction only. The other direction data transfer is not possible. So, that is the simplex mode. In half duplex mode, the transmission is allowed in both the direction, but not simultaneously. The data transfer can be done in both direction, but it cannot be done simultaneously, one at a time. And the third one is the full duplex mode, which allows the transfer of the data in both the direction simultaneously. Now, the second one is the classification is based on the transmission format, and data can be sent in two formats. One is asynchronous, second one is synchronous. I have already told you that asynchronous means at the different time, synchronous means at the same time. Asynchronous data transfer scheme is a kind of a scheme in which the data which is available from the sender side may not be received at the receiving end immediately at the same time. So, the asynchronous data transfer is a character oriented, as well as the bits of the character or the data word are sent at a constant rate, but characters can come at any rate as long as they don't overlap. So, this particular asynchronous data transfer is used for the low speed transmission of the data. Now, the data rate, which is measured in terms of bits per second or character per second, is also known as baud rate. Now, synchronous data transfer is a kind of a transfer in which the data which is being transmitted from the transmission side is being received at the receiving side at the same time. It means they are synchronized, transmission as well as the receiving is synchronized with a clock signal, and this particular is being used, synchronous format is used for the high data transfer speed. Now, as far as the interfacing is required, because we have to send, we are sending the microprocessor is sending the data parallelly and the receiver is receiving the data serially. So, there must be some interfacing devices which is required to convert the data from the parallel mode to the serial, as well as the device which is sending serial to be converted into parallel. So, we require two kinds of devices, parallel to serial and serial to parallel converter. Now, so one device which is used for this particular purpose is known as UART, which is universal asynchronous receiver transmitter, and the chip number is 8250. But another device which is USART, whose full form is Universal Synchronous Asynchronous Receiver Transmitter. It is a kind of a device which will be transferring the data synchronously as well as asynchronously. Both the schemes are possible, and the chip is name of the chip is 8251, and 8251 is it is a programmable device depending upon that how many data has to be transferred as well as the parity bits. Now, USART 8251 will be used for this particular purpose, for transferring the data from parallel to serial and serial to parallel. Both things are possible in case of USART. So, what are the features of USART? Now, it supports both asynchronous protocol as well as synchronous protocol with certain its capabilities, that in case of asynchronous 5 to 8 character formats can be used, baud rate which is used from DC to 19.2 K baud, as well as false start bit detection is also been done. And it also supports the standard synchronous protocol where 5 to 8 bit character format, as well as baud rate is up to 64 K baud. Now, this allows duplex transmission and the reception, means data can be transferred both the sides simultaneously. Data buffering is also allowed at the transmission side as well as the receiver section. It provides detection logic, error detection logic. It supports modem control logic. It is compatible with all kinds of Intel microprocessor, and it is a integrated chip having 28 pins, and it provides separate clock input for the receiver as well as for the transmission section, thus providing an option for fixing the baud rate. Now, the pin diagram of the 8251 is clear. We have a data bus which is of bidirectional tri-state 8-bit data bus, and we have a read signal, we have a write signal, we have a chip select signal, a lot of signals, clock signal, reset, CD, CS. These all signals are being used for the selection of the individual lines, so that 8251 can work properly. Now, as far as the block diagram is concerned, the block diagram is having 7 blocks. The first block is data bus buffer, then read write logic and the modem control. The fourth one is the transmit buffer, transmit control, receiver buffer and receiver control. So, these are, and it is all these devices are connected with the internal data bus, and all the lines are connected, different lines are connected to the different blocks. So, as far as the explanation of these blocks are concerned, since it includes 7 blocks, so first of all we will discuss the data bus buffer. So, as I told you that data bus buffer is a tri-state bidirectional 8-bit buffer which is used to interface the 8251, that is USART, to the system bus of the microprocessor. Now, along with the data, now the data bus will be used to transfer the data, but along with the data it is also used to send the control words and the status information, and also used to transfer to the all these facilities are also available to transfer from the data bus buffer. Now, second one is read write logic, read write control logic. This functional block accepts the input from the system control bus and generates control signal for overall device operation. Now, it decodes the control signal which is sent by the 8085 control bus into such signals which controls the internal and external input output bus. This logic contains the control word register, control word command word register, and also stores the various control formats for the device which is used for the proper functioning of the 8251. The third block is transmit buffer. Now, the transmit buffer accepts the parallel data from the microprocessor, or you can say it to CPU, and adds certain appropriate framing information and then serializing it and then transmit it on the certain pins, that is a TXD pin. Now it has two registers. One is buffer register to hold the 8-bit, and the other one is the output register to convert that 8-bit into a stream of serial bits. Now the microprocessor writes a byte in the buffer register, which is transferred to the output register when it is free, when it is empty, and the output register then transmits the serial data on the through the certain pin. Now in asynchronous mode of data transmission, the transmitter always adds certain start bits depending upon how the unit is being programmed. It also adds some optional even and odd parity bit, and either 1 or 1.5 or 2 stop bits, but in synchronous mode no extra bits are being added are being generated or by the transmitter. Now the next one is the transmit control. Now the transmit control manages all the activities which are associated with the transmission of the serial data. It accepts the as well as it issues the signals both externally and internally to accomplish the function, and for that particular purpose there are many signals, many lines which are being used, that is TXRDY, transmit ready, TXE, that is transmitter empty, that is TXC, that is transmitter clock, and so on. So it has certain purpose, and its purpose is to manage all the activities related with the transmission of the serial data. Then we have a receiver buffer. Now this receiver buffer used to work in such a fashion that it accepts the serial data and converts that serial data to the parallel format and checks the bits or the characters that are unique for the communication, unique to the communication technique, and send an assembled character to the central processing unit or the microprocessor. Now when 8251 is in the asynchronous mode, it is ready to accept a character. It looks for a low level of the certain line, and when it receives the low level, it assumes that it is a start bit and enables the internal counter. Now at a count equivalent to 1/2 or a bit time, that line is sampled again, and if the line is still low, the valid start bit is detected and the 8251 proceeds to assemble the character. Now after successful reception of the start bit, the 8251 receives the data, parity and the stop bit, and then it transfers the data to the on the receiver input register. So the data is then transferred into the receiver buffer register. So in asynchronous mode, the receiver simply receives the specified number of data bits and transfers them to the receiver input register and then to the receiver buffer register. Now the next one is the receiver control, whose functions are to manage all the receiving related activities. Along with the data reception, it also detects the false start bit detection. It does the fault bit detection, parity error detection, framing error detection, and all kinds of error which can arise, synchronous detection as well as the break detection. And for that it will be using certain signals, that is RX, RDY, that is receiver ready, and the RXC, that is a receiver clock. And the last one is the modem control. Now 8251 has a set of certain control input as well as the output that will be used to simplify the interface to almost all kinds of modem. Now it provides the control circuitry for the generation of the certain signal, which gives the information either in the form of a testing that data is ready to the output signal is used to tell the modem that data terminal is ready, or it is ready to transfer the data, and it starts beginning of the transmission. So with the help of different lines, it will be connecting, it will be managing its work to properly function the 8251. Now, there are many control words which are used in 8251. Now, the control word defines the complete functional operation of 8251, and it should be loaded before any transmission or the reception took place. So, there are two kinds of formats which are being used for this particular purpose. One is mode instruction format and second one is the command instruction format. Now, the mode instruction format, it is an 8-bit number, and this 8-bit number is divided into 4 2-bit field, and depending upon the value of these 2-bit field, it is going to work. It gives the information that how it will work. Now, as it is divided into 4 2-bit field, the first 2-bit field that is D0 and D1 is used to recognize whether it is working in a synchronous mode or it is working in a asynchronous mode. If the value is 0 0, when the value is 0 0, it is working in a synchronous mode, and asynchronous mode it is working in the other bits value, if it is 0 1 or 1 0 or 1 1. So, if it is 0 0, it is synchronous mode. If it is rest of the value, then it will be working in a asynchronous mode. Now, as far as the D2 and D3 is concerned, now D2 and D3 determines the number of data bits in one character. With this 2-bit field, we are able to set the character length from 5-bit to the 8-bit. Now, the third one, which is D4, D5, this is used to control the parity generation. Now, this parity generation is going to add the data bits only if the parity is enabled, and the last 2-bit, that is D6 and D7 bit, has two meaning, depending whether the operation is done in the operation to be done is in the synchronous mode or in the asynchronous mode. For asynchronous mode, in which D1 and D0 is not equal to 0 0, either 0 1 or 1 0 or 1 1, it controls the number of stop bits to be transmitted with the character. And in synchronous mode, when the D1 and D0 value is 0, this field controls the synchronizing process. It also decides whether to operate with the external synchronization or internal synchronization, and whether to transmit the single synchronization character or the 2 synchronization character. So, that is the description of the mode instruction format. Now, the second one is the command instruction format. After the mode instruction, the command character should be issued to the 8251 USART, and the purpose is to control the operation of USRT within the basic framework that is established by the mode instruction. Mode instruction meaning thereby mode instruction format में जो भी data डाला गया, depending upon that. Now, as far as the format of this is concerned, the format is written over here. The main function of control instruction is to enable the transmit and the receive, as well as error reset and modem control. So, this is all about the USART.